In this video, we will take a look at some solved examples related to the ISA or the instruction set architecture and which have come in GATE. So let's take the question. A processor has 40 distinct instructions and it has 24 general purpose registers and a 32-bit instruction word. That means the instruction is of 32 bits. It's specifically given over here that it is a 32-bit instruction word. So the format of the instruction is, it has an opcode, it has 2 register operands, and it has an immediate operand. So we have to find out the number of bits available for the immediate operand field. So we know that this processor has 40 instructions. So how many bits would be required to encode 40 instructions? That means how many bits would be required for the opcode part of an instruction. So the number of bits would be log of 40, right? And we take the ceiling of this. So this will come out to be 6 bits because see, you know that 2 to the power of 5 is 32. So if we use only 5 bits, we can encode at most 32 instructions. And 2 to the power of 6 is 64 bits. That means 40 instructions can be encoded using 6 bits. So for 40 instructions, that means we will require 6 bits for the opcode part. Now there are 24 general purpose registers. So again, if we take 4 bits, then we can at most encode 2 to the power of 4, which is 16 registers. So this is not, that means we need something more than 4 bits. 2 to the power of 5 is 32, or you can say log of 24 you can take and take the ceiling of it. So that gives you 5 bits. So each register encoding would require 5 bits for the registers. That means if there are 24 general purpose register, you would have R0, R1, R2 and so on till R23. Let's suppose this is these are their names. So R0 would be possibly named or encoded as 00000, 5 bits only. R1 would be encoded as 00001. That means if I have to ever refer to R1, it will always be using this code. R2 will be 00010 and so on. So for 24 register, I need 5 bits for each register. So if I look at the format of the instruction, I have the opcode, which is given that the format is opcode, 2 register operands and an immediate operand. So I have the opcode, 2 register operands and an immediate operand. 6 bits I require for the opcode and each register would require 5 bits of code. So, and we know that this total instruction is of length 32 bits, it's given. So out of this 32 bits, if we subtract 6 and 5 and 5, we would be left with 16 bits. So how many number of bits are available for the immediate operand field? They are only 16 bits available for the immediate operand field. So this is the answer, 16 bits. Let's take another example. A machine has a 32-bit architecture with 1 word long instructions. 32-bit architecture means that each word contains 32 bits. Okay, and instructions are 1 word long, and we know that 1 word is containing 32 bits. That means the instruction length is also 32 bits. So from this sentence only we can infer this, that instruction length is 32 bits. It has 64 registers. So if it has 64 registers, that means 6 bits would be required to encode each register, because we take log of 64 to the base 2. Now each of which is 32 bits long. This actually means that each register that we are having, R0 if we are having, it would be having 32 bits because it needs to store 32 bits of data. But this data is redundant. It is not required over here. Okay, this you will see later. So many a times in the questions redundant data will be given. 64 registers, each 32 bits long. That means each register can store 32 bits of data. But how many bits are required to code the register? That means to address a register or to specify a register, we need 6 bits. So like R0 would be having a code 000000. R1 would be having a code 000001 and so on. Then there are 45 instructions. So 45 instructions, again if we take the log of this and take the ceiling, it will be 6 bits for the opcode. So using 6 bits for the opcode, we can encode 45 instructions, 45 different kinds of instructions. And now the instruction also has an immediate operand in addition to 2 register operands. So there is an opcode, 2 register operands and an immediate operand. So assuming that the immediate operand is an unsigned integer. Immediate operand means when we are giving the constant values over here or the literals over here, that is referred to as an immediate operand, and this they have given that this is an unsigned integer. So what is the maximum value of the immediate operand? So we know that opcode is of 6 bits, each register is of 6 bits. So out of the 32 bits, which is the instruction length, 14 bits will be left for the immediate operand. So 14 bits we can use to specify the immediate operand. So what will be the range of this unsigned integer? If there are 14 bits, we know that we can specify numbers ranging from 0 to 2 to the power of 14 minus 1. So that means the maximum value of the immediate operand would be 16383.